Hello, my name is Martha Hoffmann. I'm a researcher at the Rainer Limor Institute in Berlin, and together with many other partners we're working on the H2020 research project ELAND. ELAND concentrates on the implementation and operation of multi-vector energy systems, and in that context RLI especially focuses on the optimization of such energy systems by developing an investment planning tool for sector-coupled energy systems. Today at the CIRUT workshop I want to present you our recent thoughts on the matter of key performance indicators for sector-coupled energy systems. Now, for single-sector energy systems, there is already an existing metric to evaluate them and also to compare them to other scenarios. However, those single-sector KPI cannot always be translated directly to a multi-vector system. The difficulty of translating the key performance indicators of single-vector systems lies within the reference flow, the denominator of some of the common parameters. For example, the LCOE, the levelized cost of electricity, are relative to the energy demanded at our certain project site. Having different energy carriers in our system, it cannot be quite clear how we should deal with these different units. As such, we propose that we should perform a weighting of our energy carriers, so that we introduce weighting factors for each of our energy carrier, based on the usable potential. We propose that for the whole sector-coupled energy system we should use electricity as a reference, and therefore we propose a reference unit which is called electricity equivalent. This can be compared to the gasoline gallon equivalent that is already quite commonly used, or the CO2 equivalent. Using this we are able to transform the KPI of single-vector systems also to the realm of sector-coupled energy systems. Now we are able to answer the stakeholder questions regarding their own energy system. One of those questions may be, how high are the upfront investment costs of the energy system? This is determined by the NPC, the net present costs. Our second question may be, how much CO2 does our company emit with the new system? Now we get to the KPI, where we actually have to include the weighting of our energy carriers within our equations. For example, how costly is the energy system per energy unit? We determine that the LCOE of a specific energy carrier is the annuity of the net present cost divided by the energy demand of a specific energy carrier multiplied by its weight. Then, how high is the renewable share of our energy system? We define the renewable share of our energy system by dividing the renewable generation multiplied by the weight of the energy carrier that was generated through the total overall generation and also grid consumption of our sector-coupled energy system, also multiplied by the energy carrier weighting factor. Then we define the degree of autonomy, which answers the question, how independent can the system operate from the DSO? Here we divide the sum of all generation multiplied by the weighting factor of energy carrier by the sum of all demand multiplied with the weighting of the energy carrier. And then as the last question is the degree of sector coupling, which is a new factor that we introduced. We define the degree of sector coupling by dividing the total energy conversion flows multiplied by the weighting factor of the energy carrier that is converted by the total energy demand of our system. Now with this KPI we can already quite well estimate how our system performs. I will illustrate this now on an example case study. Our example case study is that of a sector-coupled energy system which includes electricity and H2. We are able to calculate the net present costs and from that also the levelized cost of energy. Otherwise, we can tell about our energy system that we have a very high renewable factor of about 70%, that our degree of autonomy is actually above 1, meaning that the energy system generates more than it can actually consume, and we have a degree of sector coupling of about 18%. For us, this shows that the proposed KPI is the overview of the performance of sector-coupled energy systems. We also have to note some further research which we have to address in the future, and first of all we have to reconsider if electricity is really the best base for energy carrier weighting, or if we should use some more conventional value for this. Secondly, we have to discuss the relevance of sunk costs in our economic KPI. And then, of course, we also have to develop our KPI further and apply them to the other sides and also extreme scenarios. If you're interested in getting to know the MVS or the ELAND project, you can contact me, Marta Hoffmann, to get to know the current status